Welcome to video number 14 on the birthday paradox. Now, the birthday paradox is a result that I came across from a psychology teacher. I know it seems a bit random, but it's a mathematical result which demonstrates how things that might appear unlikely actually turn out to be quite probable. In the birthday paradox's case, this is to do with the probability of two people sharing the same birthday. Now, if you were to think about how many people you'd need to ask until you found two people with the same birthday, you might think, first of all, you might think 182 or a number around there. Then some people kind of bring that number down when they realise how many different possible combinations there could be, and the number actually comes down a lot more than what most people would expect. Turns out, if you have 23 people in a room, it's more likely than not that two of them share the same birthday. And psychologists are interested in this because they use it to demonstrate how things that appear unlikely turn out to be quite likely, and there's often logical explanations for things, and the idea of coincidence is less amazing than what it first appears. Now, we're going to look at something that's essentially the same as the birthday paradox, but I'm going to reduce the numbers down so that it becomes easier for you to number crunch at home if you want to have a go. So what I'm going to look at is a number of people coming into a classroom, and I'm asking them to think of a number between 1 and 40, and I want to know what's the probability that two of them have the same number. So to work this out mathematically, and this is the same for the birthday paradox, what I first of all want to think about is what is the probability that they all pick their own numbers. Right, no one has two numbers the same. So I'm going to create two columns on the page. One for n, the number of people coming into the classroom, and then I'm going to look at the probability that all the numbers are different. Now, if one person comes into the room, no big deal. There's no one else to pick a number, so the probability that they pick something that's different to everyone else has got to be 1. The way I'm going to write this down, though, I'm going to write it as 40 out of 40, because they've got 40 numbers they can pick out of the 40 numbers that are available. I know this looks a bit silly, but as we work through, it might make a bit more sense. If I have two people come in, that means the first person's picked a number, 40 out of 40, and the second person would have to pick a different number to the one that the first person picked. So they've only got 39 out of 40 numbers they can pick, and that's a probability of that happening. Loads of simplifications I could do here. I might put in something in this third line. So for the third line, my numbers at the top can be 40 for the first person, 39 for the second person, they can't pick the same as the first person, and then the third person that comes in is going to have 38 numbers left that they can choose out of the 40 numbers. So I can write it like that. 40 out of 40 times 39 out of 40 times 38 out of 40, using the 40 cubed at the bottom to make it a little bit easier. When number 4 comes in, I'm going to end up with quite a lot of terms here, but I can see a pattern, so it's going to be quite quick to write down if I wanted. But to think ahead about how I might write these down, I might want to use factorial notation. Now, A-level mathematicians will be familiar with how factorial works, but they might not be sure how to apply it to this. So if I want 40 times 39 times 38 times 37, if I have 40 factorial, which will multiply them down to 1, and then divide by all the ones I don't want, which is 36 down, and that will leave me with 40 times 39 times 38 times 37. And I still need to divide by the correct number of 40s, so in this case 40 to the power 4. Now that's quite a neat way of having it, and at the moment my calculator is quite happy, and because I'm only going up to 40, my FX83 GT won't die on me. It'll be able to handle those, although later on in the task I'm going to set you a challenge to find, and it's going to be a number bigger than 40 that you need to work with. So you might want to consider using the permutations button, which is NPR button on the Casio FX series. It's above the multiplication sign, so use your shift, and now you might want to have a quick look up as to how that works, but essentially it does this bit for you, so you might want to have a look into that. Now rather than writing 5, I think I'm going to go to an nth term now. So if I have n number of people, I can see all these are going to have 40 factorial at the top. And I need to divide by the bits I don't want. Well, when I had 4, I divided by 36 factorial, and each time this is going to be going down by 1. So it'd be fair to say I want to divide by 40, take away n factorial. And you can probably also see that I've got 40 to the power 4, 40 to the power 3 with the respective values for n. So here I'm going to have 40 to the power n. And that's going to be my general term for this problem. This here is the probability for n number of people that no one picks the same number when I ask them to pick a number randomly out of 1 to 40. Now I do know, before someone puts a smart Alec comment down the bottom, I know it's not equally likely that everyone picks a particular number. For example, if I ask you to pick now a number between 1 and 10, I know that 7 is quite likely, and it's certainly not even. So I know that is an issue. I'm having to treat this as if everyone's picking completely randomly, and I'm going to get my calculator to work out these values, and then I'm going to convert them, because I don't want the probability of everyone picking different numbers. I want the probability that people pick the same. So to get those, all I need to do is have 1 take away these figures. Okay, so I'm just going to work them out. In fact, I'll do a bit of blue pizza now, because here's what I prepared earlier. Here they are. Now very quickly, we can see if there's one person in the room, there's a 0 chance that 2 people have the same number. And it's very unlikely when we have 2, 3, nearly 15% chance when we have 4 people in the room. But this one I'm interested in. 8 people. Once I have 8 people in the room, it is more likely that 2 people will pick the same number when asked to pick a random number between 1 and 40 than not. I think that's quite interesting. I know it's not as impressive as the birthday paradox, but still, I think that's interesting. Now, my problem for you though today is related to this. I want to know what number I should pick. So the birthday paradox is out of 365. That example there was out of 40. But what number should I pick so that if I have 20 people in the room, are more likely that 2 of them pick the same number than not? In effect, well, let me help you out. I know the number's going to be more than 40. I know the number's going to be less than 365, because when there's 365 that needed 23 people. But I want to know the largest number that I can ask 20 people to pick a random number between, such that it is more likely than 2 of them pick the same number as each other than don't. Good luck.